In 1911, Einstein left Switzerland after over 15 years there to take up a new position which had been offered to him at the Charles Ferdinand University in Prague, the oldest university in what is now Czechia, but which was then a constituent part of the Austro-Hungarian Empire. In tandem, he was offered Austrian citizenship. Although he spent just over a year there, he published upwards of a dozen papers on topics such as the mathematics of radiation, quantum theory, and gravitation. Before long, a new offer pulled him back to Switzerland. This was an invitation to teach at his old alma mater, the Polytechnic School in Zurich. He was there by the summer of 1912 and would spend the next year lecturing to classes who were increasingly familiar with the growing fame of the German physicist, while also researching problems on gravitation and molecular heat. Much of this latter work was undertaken in conjunction with Marcel Grossmann, the Swiss colleague who had attended the Polytechnic with Einstein in the late 1890s and whose family had aided him in acquiring his earlier position at the Bern Patent Office. In the spring of 1913, less than a year after taking up his position in Zurich, Einstein was visited in Switzerland by Max Planck and Walter Nernst, two of the foremost scientists of the age. Both worked in Berlin and had come to Zurich to convince Einstein to return to the land of his birth to take up a position at the University of Berlin. The post came with automatic membership of the Prussian Academy of Sciences, as well as his appointment as director of the Kaiser Wilhelm Institute for Physics. This would allow Einstein to concentrate on his research and build a team of researchers around him. It was an offer he couldn't refuse, and was made more attractive by the prospect of being close to his cousin Elsa, who lived in Germany and whom Einstein had begun corresponding with frequently since the spring of 1912. Thus, early in 1914, Albert made the move to the German capital. His first wife, Mileva, agreed to move at first with their two sons, but she was immediately unhappy in Berlin and sensed Albert was growing closer to his cousin, and soon decided to return to Zurich with their children. They remained separated until 1919, when they finally divorced, at which time Einstein married Elsa. By then both she and Albert were in their 40s, and this second marriage of Einstein's did not result in any further children, though Albert became stepfather to Elsa's two daughters from her previous marriage. Einstein's arrival in Berlin was immediately interrupted by the outbreak of the First World War. For years, tensions had been building between the major European powers over issues as disparate as colonial rivalry in Africa, the vacuum left by the collapse of Ottoman power in the Balkans, and the naval race between Britain and Germany. These all coalesced in the summer of 1914 into the outbreak of a pan-European war, which soon became a worldwide conflict. When it erupted, and Germany's invasion of neutral Belgium as a means of striking quickly at northeastern France drew widespread international condemnation, a document entitled Manifesto of the 93 and addressed to the civilized world was soon being circulated in Germany. The move was led by figures like Adolf von Baeyer, the 1905 recipient of the Nobel Prize in Chemistry, and Paul Ehrlich, the 1908 recipient of the Nobel Prize in Medicine for his pioneering work in chemotherapy, and was effectively a letter from dozens of prominent German academics sounding their support for Germany's war effort. Einstein, who was a lifelong pacifist, refused to sign it, and instead, with several other German academics, drew up the Manifesto to the Europeans. This expressed the idea that Europe's sense of common culture could be harnessed to bring the war to a swift end. Unfortunately, their hopes were not met, and the war was to drag on for 4 more years of interminable conflict, followed by years more of revolution and civil war across much of the continent. Despite the ongoing war, Einstein was able to commence new research in a concerted manner in Berlin from 1915 onwards as the initial shock of the outbreak of the war lessened. However, it was not until 1917 that the Kaiser Wilhelm Institute was finally established in Berlin with Einstein as its first director. Funding and administrative delays wrought by the war effort had delayed its inception. He would serve as head of the institute for the next 16 years. Meanwhile, in 1916, he was admitted as a member of the German Physical Society, which had been established in 1845, and is the world's oldest major academic body of physicists. Foreign honours would also follow in the years ahead, including membership of the Royal Netherlands Academy of Arts and Sciences in 1920, and admittance as a foreign member in 1921 to the Royal Society, arguably the world's most prestigious scientific society and one which dated back to 1660 when it was founded in London. Such honours aside, Einstein continued to break new ground in his research in the mid-1910s. For instance, in 1916, he hypothesized the existence of gravitational waves, which are effectively ripples in the curvature of space-time. These could not be detected using the instrumentation available in the early 20th century. But in 2016, a century after Einstein predicted their existence, they were finally confirmed by American scientists. He was also beginning to theorize the existence of what we now know to be black holes, points in space where gravity is so strong that neither light nor particles can effectively escape from them and which distort space and time. As with so much else, his work on black holes was pioneering and paved the way for many of his successors to produce detailed accounts of the building blocks of the universe later in the 20th century. He could, however, be mistaken too. In 1917, he began working on what he termed the cosmological constant, a theory which supposed the existence of a static universe. Many years later, when the American astronomer Edwin Hubble discovered the recession of nebulae in the universe, Einstein realized his earlier theory of the cosmological constant was incorrect and referred to it as his, quote, biggest blunder throughout his career. His other great research project of the war years, though, was far from a blunder. Einstein had been working on the concept of relativity for over a decade, and special relativity was the subject of one of his acclaimed papers of 1905. Yet it was not until the mid-1910s that he began finalizing his research on the subject of general relativity. The general theory of relativity outlined the geometric theory of gravitation. This moved far beyond Newtonian ideas concerning gravity to explain gravitational pull and the full complexity of geometric gravity as it applies to the universe and not just individual planets. There is an ongoing debate as to who actually arrived at the general theory of relativity first, as his contemporary, the German mathematician David Hilbert, essentially arrived at nearly identical conclusions as Einstein did in the mid-1910s. As with Charles Darwin and Alfred Russel Wallace, who both broadly developed the theory of natural selection at the same time in the mid-19th century, both Einstein and Hilbert were in communication with each other, and Einstein had visited the University of Göttingen, where Hilbert was working in 1915, to present lectures on his own findings. What seems relatively clear is that Einstein and Hilbert influenced each other sufficiently that they both arrived at the same conclusions concerning general relativity within days of each other in the winter of 1915. In late 1918, Europe and the wider world began to emerge from the grip of the First World War, although in some countries such as Russia, Hungary, Turkey and Ireland, the end of the war saw the commencement of bitter civil wars which eclipsed anything that those countries had seen during the war itself. Yet, with the resumption of some form of normal life, academic discourse resumed fully, and research began to be disseminated widely again. Thus, Einstein and Hilbert's work on the general theory of relativity reached a wider audience within the community of Europe and America's physicists. As it did, there was an increasing appreciation of how groundbreaking their studies were. Then, in the summer of 1919, the theory was confirmed as being accurate by Sir Arthur Eddington, an English astronomer and mathematician, during a solar eclipse. This time, the popular newspapers picked up the story, proclaiming that Einstein's theory had overthrown the model of the universe developed by Isaac Newton nearly 250 years earlier. Given all of this, it is perhaps unsurprising that in 1921, the Nobel Foundation in Stockholm decided to award Einstein the Nobel Prize for Physics. They specifically cited his work in discovering the photoelectric effect in his paper from 1905 in the award designation, but it could just as easily have been awarded for a wide range of research findings over the previous 15 or so years. Receipt of the Nobel Prize in 1921 and the opening up of the world during the boom time years of the 1920s after years of war and social discord saw Einstein and Elsa, whom he had just recently married, decide to travel internationally. In early April 1921, they sailed into New York City, where the couple were greeted by the mayor, John Francis Hylan, and a delegation of some of the most senior members of the city's Jewish community. Weeks of lectures and receptions followed, notably at Columbia University in New York and Princeton University in New Jersey. Later that month, Einstein met President Warren Harding in the White House. Afterwards, they left for a Pacific voyage to the Empire of Japan, and then onwards to Singapore and India before reaching the Middle East. There, Einstein visited Palestine, which had become subject to a British mandate following the end of the First World War, and where the Jewish Zionist movement was attempting to establish a new state for the world's Jews after centuries of being scattered around the globe. Afterwards, he returned to Germany. But the 1921 to 1922 trip was the beginning of a pattern of significant trips to different parts of the world. For instance, in 1925 he visited South America, spending weeks in Argentina, Uruguay and Brazil, countries which were booming economically and socially in the early 20th century and where Einstein was revered within the academic community. In the mid-1920s, Einstein became involved in a scientific debate which was widely reported on at the time. This was between himself and Niels Bohr, a Danish physicist who had won the Nobel Prize in Physics in 1922, 12 months after Einstein had been awarded the same honor. A dispute had been building between Einstein and Bohr throughout the mid-1920s over their differing interpretations of quantum theory. Much of this centered on Bohr's refusal to believe that photons, which Einstein had first theorized the existence of in 1905, were real. He did not accept that they did exist until 1925, and even then, their debates raged on over other elements of their respective views on quantum mechanics. Debates were held in London and elsewhere between 1922 and 1925, but culminated in a famous academic disputation in 1927 at the 5th Solvay Conference at the International Solvay Institutes of Physics and Chemistry in Brussels. Here, Bohr and Einstein continued their debate, with both figures arguing points which eventually proved to be accurate. However, beyond the theoretical arguments, the conference is noteworthy for the number of the world's most accomplished physicists it drew together. 17 of the 29 attendees had already or later received Nobel Prize awards, while Einstein and Bohr were joined by figures including Marie Curie, Werner Heisenberg, and Erwin Schrödinger. It points to the sheer level of brilliance of the scientific community in the interwar period. The late 1920s also saw Einstein reconceptualizing his own theories of the universe. This was in response to the discovery by the American astronomer Edwin Hubble of the recession of the nebulae, or what is now termed Hubble's law. This states that galaxies are moving away from Earth at speeds which are proportionate to the distance they are from the Milky Way. These speeds are always faster, meaning that the further a cosmic body is from the Earth, the faster it will move away from the Earth. These findings, which were made public in 1929, required Einstein to abandon his current theory of the universe at that time, which was known as the cosmological constant, which supposed that the universe was largely static in the way that it expanded, that is, that the cosmos had been expanding since the Big Bang at a relatively constant speed. Hubble's discoveries forced Einstein to re-evaluate his hypothesis, as it was now clear that the universe was expanding at an ever greater speed. Hubble's discovery was also partly responsible for Einstein's decision to embark on a new journey to the United States in December 1930. He wanted to meet Hubble and thank him for his research, which he duly did in 1931. However, the trip is generally more remembered for Einstein's visit to California, where the ostensible purpose of the voyage was to take up a 2-month visiting fellowship at the California Institute of Technology, better known as Caltech today. During this sojourn, Einstein ominously noted that science had as much and perhaps a greater capacity to do harm than to do good within human society, a reference no doubt to the increasing use of technology in warfare, an issue the pacifist Einstein found abhorrent. This same aversion to the growing militarism of the 1930s led Einstein to have an affinity with the novelist Upton Sinclair and the actor Charlie Chaplin, both of whom he met in Los Angeles during his visit, and who were both publicly affirmed pacifists themselves. Einstein's growing friendship with Chaplin led him to attend the premiere of his new film, City Lights, a silent film which was significant in establishing the romantic comedy genre in American movies. When Albert and Elsa Einstein entered the cinema with Chaplin, Einstein was cheered with the same regard a Hollywood icon could obtain. It was also the beginnings of a long friendship with Chaplin, which saw the actor visit Einstein's Berlin apartment shortly afterwards, and Einstein renewed their acquaintance when he himself returned again to America early in 1933. While Einstein had been holding his positions in Germany and traveling widely in the 1920s and early 1930s, as his fame and accomplishments increased, the political environment back in his native Germany was changing for the worse. Germany had been mired in political chaos in the aftermath of the First World War, but from 1923 onwards had entered into a period of pronounced prosperity and instability. That was shattered late in 1929, when the stock markets on Wall Street in New York City crashed and a massive economic depression set in across the developed world. In Germany, as millions lost their jobs and their economic security, a huge proportion of the population turned in national elections to the rabidly anti-Semitic National Socialist German Workers' Party, or Nazis, under their leader Adolf Hitler. In Reichstag elections in 1932, they became the largest political party in Germany, and in the first months of 1933, Hitler became Chancellor of the country. Within weeks, the party effectively turned Germany into a one-party fascist state. This was extremely ominous for the country's Jewish population and individuals like Einstein. In the United States, he decided not to return to Germany, and instead the Einsteins settled in America after a brief visit to Antwerp in Belgium, where Albert handed his German passport into the German embassy and renounced his citizenship. In Berlin, the Nazis had already searched his apartment twice on account of his Jewish heritage, and over the next year or so, Jewish academics such as himself were forced out of their positions across Germany. In the United States, following his decision to seek permanent residence there in 1933, Einstein quickly acquired a position at the Institute for Advanced Studies at Princeton University in New Jersey. It was the institution which he would spend the longest portion of his career at, and, barring a directorship at Brandeis University in Massachusetts in the mid-1940s, Einstein was primarily associated with Princeton for the remainder of his life. In the mid to late 1930s, Einstein undertook some further notable work here on the east coast of America. A particularly significant engagement resulted from collaboration with Nathan Rosen, a Jewish-American physicist. Together, Einstein and Rosen produced a model of what a wormhole might look like. Wormholes are theoretical structures which might connect disparate points in space-time together. At the time that Einstein and Rosen produced their theoretical wormhole bridge, they were a relatively novel concept, but they have latterly come to form a fundamental aspect of theoretical writings on space travel. In due course, they became a mainstay of science fiction writing from the middle of the 20th century onwards. While Einstein was teaching in the United States in the 1930s, developments were occurring back in his homeland of Germany, which would soon have global implications. Following their initial rise to power in 1933, the Nazis had made clear their intent to overturn the terms of the Treaty of Versailles, which had brought the First World War to an end. In the mid-1930s, they began rearming Germany, recruiting hundreds of thousands of soldiers into the military and building thousands of tanks, fighter planes and bombers. Then, beginning in the spring of 1938, the Nazis used diplomatic coercion to annex Austria into a Greater Germany and to seize territory from its other neighbors such as Czechoslovakia and Lithuania. When Hitler then invaded Poland in September 1939, Britain and France determined that they could no longer appease the Nazis and declared war on Germany. In the immediate term, the government of President Franklin Delano Roosevelt did not have public support for American involvement in what was deemed within the US to be a European war which it should not involve itself in. However, when Germany's ally, the Empire of Japan, attacked the US Pacific Fleet at rest in Pearl Harbor in Hawaii in December 1941, the United States also entered the Second World War. More than any war in human history, it was one which would be shaped by scientific innovation. Despite his pacifism, Einstein was soon involved in correspondence with the US government concerning the growing conflict. Indeed, this had commenced weeks before the war erupted in Europe. Early in 1939, European physicists had discovered nuclear fission using uranium. With this discovery, the theoretical possibility of developing a nuclear bomb of some kind moved ever closer. A number of European physicists, foremost amongst which was the Hungarian Leo Szilard, realized exactly how possible it now was that a dedicated research team could develop a nuclear warhead. This deeply worried many European scientists, as many of the continent's leading physicists worked in Germany and could be co-opted into helping the Nazis develop a nuclear weapon, one which Hitler and his accomplices would have little compunctions about using as a conventional weapon of war, despite its absolutely cataclysmic capacity for the loss of human life. Consequently, Szilard and two fellow Hungarian physicists, Edward Teller and Eugene Wigner, composed a letter to the US government warning of the risks of the Nazis developing a nuclear weapon before any other state. They sent this to America, where Einstein appended his signature to it before it was sent to the administration of President Roosevelt. What has become known as the Einstein-Szilard letter was influential in the months that followed in the US initiating its own program to develop a nuclear weapon.